Yeah. Good morning, my dear students. Here I am discussing test paper 8, gravitation chapter, solutions in detail. Okay. First question. Force between two objects of equal masses. Okay. This is the mass is what M and another mass is what M here. Okay. Equal masses is what F. That we know that equation F equal to G into M divided by what? D square. This equation we know that. Okay. Now what it is doing is, if 25% of mass of one object, okay, now it is transferred, 25% is transferred. By losing 25%, it becomes 75%. This will become what? 125%. And what is the new mass? Here M is changed now, so that F dash equal to G into M divided by D square. This is 75% means that is 75 by what? 100. This will become what? 125 divided by what? 100. Then simplify it. This becomes 25 3 ja, 25 4 ja. This is 25 ja, 25 4. This becomes 5 into 3, 15. 15 by 16. That is what? 15 by 60. It is all together. It is what? F here. So that F dash equal to F into 15 divided by what? 60. So that this is the right choice. Next. If GH and GD with the acceleration due to gravity at a height h above the Earth's surface and at a depth d below the Earth's surface respectively, if GH equal to GD, we know the relation GH equal to 1 minus 2h divided by what? R. With respect to depth equal to 1 minus d divided by what? R. In the problem only has given GH equal to what? GD. So then simplify it. This is 1 minus 2h by R equal to 1 minus d divided by what? R. So that you're comparing, so that you'll get 2h by R equal to d divided by R, or else d equal to what? 2h. D equal to 2h. This is the right solution. Next, quickly. As you move from the equator to the poles, the value of G here. For this, you have to use the equation. We know that Earth is an elliptical in what shape here? Okay. This is called as a major axis, and this is what? Minor axis. Here, suppose object is here or satellite is here. This angle is what? You have to use the equation G dash equal to G minus of what? R omega square into what? Cos square of what? Lambda, that is. Here at the equator, student, at equator, this angle lambda equal to what? 0 degree. Then cos 0 equal to what here? Cos 0 equal to what? 1. Then G dash equal to G minus of what? R omega square. It is the equator. Next, suppose satellite is here. Now gradually it comes here, this here. At this point, this angle is what? 90 degree. At poles, lambda equal to what? 90 degree. Then what about cos 90? Cos 90 equal to what? 0. So that this equation becomes G dash equal to what? G here. That means as we move from equator, this is the equator, to what? Polar region here. Now the G value will be what? Increases here. It will be increases. It is increases. This is the right choice. And remember, students, always G is maximum at the what? Polar region. G is maximum, that is here at the polar region. And G is minimum at equator region. G is what? Minimum. Okay. Next. Based on the same thing, that is, he is asking what is the value of G at angle is what? 30 degree, that is, with respect to what? Major axis. G dash equal to G minus of what? R omega square of what? Cos square of what? Lambda. Here G at 30 is equal to G minus R omega square. What is cos lambda? Cos of 30. Lambda equal to what it is now? 30 degree. Equal to root 3 by 2 is there now. Square it becomes 3 by what? 4 here. Now transfer the term here, so that G minus G30 equal, I will transfer this term on this side here, equal to 3 by 4 into what? R into what? Omega square. This is asking G minus G30, so that this is the right choice. Next, if the acceleration due to gravity G is what? 10 meter per second square at the surface of the earth, then at a height of what? 1600 kilometer he is asking. That is okay. Now with respect to what? Height, G dash equal to G into bracket 1 minus 2h divided by R. You substitute this. G dash equal to G into bracket 1 minus height is how much? 1600. That means 2h equal to what? 2 into what? 1600 equal to how much? 3200. So that this is 3200 divided by what? 6400. So that this 32 this becomes G dash equal to G into bracket 1 minus 1 by 2 equal to G by what? 2. Then G will be what? 1 by 2. 1 by 2, nothing but it is G equal to how much has given? 10 has given. So that G dash equal to G by 2 equal to 10 by 2 equal to 5 meter per second square. This is the right choice. Next, the radii of two planets respectively R1 and R2 and their densities ρ1 and ρ2. Students, I now want to send equation G equal to Gm divided by what? R square. G equal to G divided by R square. Mass I am writing in terms of volume and density I am writing. Density equal to what is the formula? Mass by volume. Therefore, mass equal to what? Rho into what? V. It is rho into 4 by 3 pi into what? R cube here. Can I reshuffle the terms now? This R square is get cancels. What is left? Rho into what? R. Constant factors are what? G into what? 4 by 3 of what? Pi. Of course, all these are constants. Here, G is directly proportional to rho into what? R. Using this formula, so that G1 by G2 equal to rho1 R1 divided by rho2 what? R. In the ratio form, I am keeping G1 is to G2 equal to rho1 R1 into rho2 into what? R2. Students, this is the important formula. Many times the problem is occurred, the relation between the density and G. So that D is the right choice. Next, the height at which the body becomes 1 by 16th of its weight on the surface. Okay. One weight depends upon weight equal to m into g. Always m will not change, students. Either you go to the any planet you go, mass will not change, but weight will what? Change here. Here weight changes because of g, that is. Indirectly has given g dash equal to what? 1 by 16th of g. That you have to understand. Here weight equal to m into g, but mass will not change, but g will what? Change. Okay. Now use the equation g dash equal to g into bracket 1 into bracket 1 plus h divided by r whole square. Only 3 standard formula with respect to depth, with respect to height, and with respect to what? Rotation here. Okay. G dash equal to what? 1 by 16 of G equal to G into bracket 1 plus H by R whole square here. This G get cancels. Here, can I take the reciprocal of it? That is 16 equal to 1 plus H by R whole square. Next job is what? Taking the square root. The square root 4 equal to 1 plus H divided by what? R. Simplify it. Therefore, H by R equal to 4 minus of 1 equal to what? 3R. That means H equal to 4 minus 1 equal to 3. Therefore, H equal to what? 3R. This H equal to 3R. This is the right choice. Okay, some shortcut methods also you have to follow. Whenever you have to go, whenever this is, if you go at a height of what? 3R. This is the what? 3R. This 3R means this should be what it is? 2R it is. Because this is what? R. Your G value will becomes what? Decrease. How many times it becomes here? 1 by 16th. That is 1 by 16th. Okay. This tricks you have to remember in the shortcut methods. Suppose your weight is 80 kilogram on this 80 kilogram. What is the weight on this? What is the weight of at this height? At this height means what? Double the radius, where it becomes 1 by 16th of 80. That means just it becomes what? 5 meters. Of course, it is not required. This is the trick we have to remember. Next, 8th. If the earth rotates faster than its present speed, the weight of the object will be. Earth rotates faster than its present speed. Okay. Rotation and G related by G dash equal to G minus R omega square cos square divided by what? Lambda. Here, as omega increases, you are subtracting more quantity, so that G dash will be what? Decreases. So that decreases, it is only one choice is there at the equator, but remains unchanged at the what? Poles here. Because why it remains unchanged? Lambda equal to what? 90 degree. Cos 90 equal to what? 0. Next. In some reason, the gravitational field is what? 0. Gravitational field is 0. What is the gravitational potential, student? Gravitational field equal to, it is similar to the electric intensity. Gravitational field equal to d by dx of gravitational potential, that is gravitational potential, that is this one equation. Okay. Here in the problem, he has given that it is 0. Gravitational field equals 0. That means when you are getting 0, differentiation of any constant quantity, it must be a constant. It must be a constant. So that it must be a constant. Okay, student. If the question 10th is wrongly, it is typed here. Go through your notes, question paper, where question is like this. 1 minute, I will change this question. Okay, now I will add it. What is that question? The ratio of mean distances, the ratio of mean distances, the ratio of mean distances from the sun are 0.5 is to 1 is to what? 1.5. Okay. Then find ratio T1 square, T2 square into what? T3 square. You have to find this ratio. Okay. Students, in this problem he has given the R1 is to R2 is to what? R3 equal. 0.5 nothing but 1 by 1 as it is. 1.5 nothing but what? 3 by 2. How T and R related? According to Kepler's law, T square is directly proportional to what? R cube. So that can I write T1 square, T2 square, T3 square is directly proportional to what? R1 cube, R2 cube, it is what? R3 cube. It is R1, it is 1 by 2 means 1 by 8. This is 1 by 1. This is cube means what? 27 divided by what? 8. Then simplify it. T1 square, T2 square, it is T3 square is directly LCM is 8. So that 1 is to 8 is to what? 27. So that in your choice, 1 is, that is C is the what? Right choice in your question paper. Next. Eleventh question. An object weighs 72 Newton on the earth. What is the weight? 70. What is its weight at a height of what? R by 2. Okay. Here, as I told you, weight depends upon what? G, that is. Now our job is to find what is the acceleration due to gravity at a height. At a height h equal to what? R by 2. That you have to find it. What is the acceleration due to gravity at a height R by 2? We have to find it. Okay. Use the equation. G dash equal to G into bracket 1 divided by what is that? 1 plus h divided by r whole square. Okay, fine. Here it is r get cancels. G dash equal to G into bracket 1 plus 1 divided by 2 whole square. Here r will be get cancels because h by r how to write? R divided by 2 divided by r get cancels. You are getting what? 1 by 2. Simplify it. G dash equal to G into bracket 1 plus 1 by 2. 1 plus 1 by 2 equal to what? 3 by 2. That is 3 by 2 square. 3 by 2 square means 9 by what? 4 here. Or else G dash equal to G into bracket 4 by 9 here. That means acceleration due to gravity, tell me now, is it increase or decreases? It is decreases. How many times it decreases here? 4 by 9 times. When G decreases, then weight is also what? Decreases. How many times? 4 by 9 times. That means W dash equal to 72 into 4 by what? 9. Or else you can write W equal to M into what? G dash also you can write it. So that this is 9 1 ja, 9 8 ja. So that W dash equal to 32 kilogram. That is not 32 kilogram. It is 32 Newton. It is 32 Newton. Next. Problems related to the escape velocity. Okay, fine. Students, remember one hint here. Escape velocity is always maximum on the surface of the earth. This is the escape velocity. On the surface, it is what? 11.2 kilometer per second is there. And as I go above the earth's surface, escape velocity VE dash is always less than V. Remember this hint. As I go above the earth's surface, then what happens? The escape velocity will go on what? Decreases. Remember. That means escape velocity equal to formula 2gm divided by what? R. What is that? Escape velocity is inversely proportional to what? Radius. This is no. Okay. Escape velocity and distance, how they are related here? Inversely related. But this is the relation. This is small r. Okay. Here in this problem, at a height 7r, he is saying that it is 7r. This is the height. Height equal to 7r. But total distance, it becomes what? This small r equal to r plus of what? Sorry, r plus 7r equal to 8r it becomes. That he is asking, what is the escape velocity? Can I write VE dash divided by VE equal to square root of what? R. Okay, R divided by square root of inverse relation of it is what? R dash I am writing. Or else escape velocity at a height h divided by escape velocity on the Earth's surface equal to square root of this distance is what? R on the Earth's surface divided by R at what? H I am writing. Okay, fine. I hope that you understood, because how they are related here? Inversely related. Now, VE at height h divided by this is what on the Earth's surface is what? VE equal to radius is what? R. Here it is 8r here. So that this get cancelled. So that V at height h equal to V into 1 by square root of 8. 1 by square root of 8. Can I write like this here? 1 by square root of 8 to root 2 I am writing. So that V divided by what? 2 root 2. Is that? Because square root of 8 I can write it square root of 4 into what? 2 equal to 2 root 2. So that it will be decreases here. Of course, in all these cases it decrease. Divide by something is there. Okay. This is the next. Remember students, escape velocity and distance, how they are related here? Inversely related. Next. The escape velocity on the surface is 11.2 kilometer. Okay, fine. What would be the escape velocity on the surface of another planet of same mass but 1 by 4 times the what? Radius. Okay, see. Radius decreases. Escape velocity inversely proportional to what? This radius or distance. If r decreases, escape, no, it is square root is there. Then escape velocity is what? Increases. We know that. Escape velocity and radius, how they are related here? Inversely related here. Okay. He has said that the radius of the planet equal to 1 by 4 times of what? Radius of the Earth. There has given. Okay. Now, escape velocity on the planet divided by escape velocity on the Earth equal to, can I write like this? Radius of Earth divided by radius of the what? Planet. Is it right? How they are related? Inversely. Okay. Escape velocity on the planet divided. What is the escape velocity on the Earth here? 11.2 equal to square. What is radius of the Earth is what? R. And radius of the planet is what? R divided by what? 4 here. So that this R get cancels equal to square root of 4. Square root of 4 equal to what? 2. So that escape velocity on the planet equal to 11.2 into 2 equal to 22.4 kilometers per second. That's right. Quickly you can do it. Remember, as you go above, escape velocity will be what? Decreases here. Decreases. Decreases means R decreases. Okay. R decreases, escape velocity will be what? Increases. Increases means it is more than 11.2. It is not possible. This is not possible. Only these are the two choices. Here. Okay. Like this. Next. 14th. Interesting question that is. A satellite moves eastwards very near the surface of the earth in equatorial plane. At speed is what? V naught. Fine. The satellite is what? Rotating around the earth. With speed is what? V naught. Another satellite moves at the same height with the same speed in the equatorial plane towards westwards. Find the approximate difference in the two time period. It's a very conceptual question, students. This is your earth. This is the equatorial region. This is what? Here it is a sun. I told you several times, in the equatorial, when the sun, when the planet or when the satellite is here, that is, when the satellite is here, see, distance between the sun and the satellite is what? More. So that kinetic energy is less. Kinetic energy is less means the speed of rotation is what? Less. When the speed is less, time period is what? More here. Very slowly it rotates here. Slowly rotates here. So then this is east. Here rotates slowly means time is more. T east is more here. Understand this. And another satellite rotates in the west plane. In the west side, what happens now? Here your satellites now, where the speed of the satellite is more, kinetic energy is more. When the speed is more, time is what? Less here. Time is less. This is the concept. Here T is more and T in the west side, it is what? Less. We have to use this equation. Time period omega equal to, we know that 2 pi r divided by what? T. We know this. This relation you have to use it. Here, students, T on the west side, T on the east equal to 2 pi r divided by. As I told you, that is, in the east side, the satellite rotates very slowly. It rotates. Slowly it rotates means T is more. T more means denominator should be less. V naught minus r omega. This is the equation. Because denominator quantity less, so that T. But on other side, on the west side, equal to 2 pi r divided by V naught plus of what? R omega. Because earth will rotates from west to what? East. Okay. This is equation number 2 here. Okay, fine. He is asking, the difference is asking, which is less here, which is more? This one is more. So that T of east minus T of what? West equal to 2 pi r is a common factor. 2 pi r is a common. It is 1 divided by V naught minus r omega minus 1 divided by V naught plus of what? R omega. It is just like A minus B, A plus B. A square minus B square here. A square minus B square means V naught square minus R square omega square. This is not possible. This is not possible. Only possibility is what? Either C is right or else what? D is what? Right here. So that this is equal to 2 pi of R into bracket 4 V naught square minus R square into what? How it is? A minus B, A plus A square minus B square. LCM will take it. V naught plus of what? R omega minus of V naught plus of what? R omega. So that this get cancels here. This is equal to 2 pi R into R omega, R omega. How much? 2 R omega divided by what? V naught square minus R square omega square. 2 into 2, 4. 4 pi R square. This is equal to 4 pi R square into omega divided by what? V naught square minus R square omega square. So that here omega square is there, no? This is wrong. So that this must be the right answer. Infinite bodies each of mass 3 kilogram are situated at a distance of what? 1 meter, 2 meter, 4 meter and 8 meter respectively. The resultant intensity of gravitational field will be, okay, fine. Of course, in the regular class I have not done this problem. Gravitational intensity equal to Gm divided by what? R square. This is the formula. Gravitational intensity. Just like in the electrostatics also, electric intensity equal to 1 divided by 4 pi epsilon naught into Q divided by what? R square. Same thing it is. Of course, G and M comes. Okay, fine. All are 3 kilograms is there, no? 3 kilograms. But first body is at a distance of what? 1. Second body, 2. Third body is what? 4. Next, fourth body is what? 8 meter, like this. No? Here, 1 and okay. Then how to write this equation, that is. Okay. This is the norm. Now, I equal to, can I write like this? I equal to G into what? M into bracket 1 by R1 square plus 1 by R2 square plus 1 by R3 square plus so on. Here 3 is constant. 3 is what? Constant. Okay. I equal to G into what? M into bracket 1 divided by R1. This is R1. It is 1 plus R2, 1 by what? 4 plus it is 4. It is what? 1 R2 square. R2 square. Okay. Then next one is 1 divided by what? 16. You know the series? 1 plus 1 by x plus 1 by x square series, you know that. So that here R becomes, it is 1 by 4. It is second term divided by previous term. Third term divided by what? Second term. You know, in the mathematics you know that. I equal to G into M into bracket 1 minus 1 minus of what? R here. What is R here? R equal to, I equal to what? G into M 1 divided by 1 minus 1 by 4. Substitute this. This becomes G M into 1 divided by 1 minus 1 by 4. It becomes 3 by 4. It becomes 3 by 4. Can I write in this form? G into M divided by what? 4 by 3. But here the mass is given here. What is the value of mass? 3 kilogram. So that I equal to G into 3 into what? 4 by 3. This get cancels. It becomes 4G. This is the right answer. Students, please note down, this problem I have not solved the regular class level. Similar kind of problems comes in the electrostatics also. Okay. This formula you should know that, series formula. Next. 3 equal masses of 1 kg each are placed at the vertices of an equilateral triangle PQR. Okay. Okay. Draw the diagram. This is this. This is P, this is Q, and this is what? R. 3 equal masses. Here it is 1 kilogram. Here it is 1 kilogram. And here also 1 kilogram masses are placed. Draw the diagram. And a mass of 2 kilogram is placed at the centroid. This is the centroid. Here 2 kilogram. This I will call it as a what? O. I will call it as O. Okay. That which is at a distance of square root of 2 meter from each side of the vertices. That means the distance has given this distance, this distance, this distance. Here OP equal to OQ equal to OR equal to square root of 2 meter as given. Fine. Now, what is the force acting on the mass 2 kilogram? What is the force acting? Okay, fine. Now, students, Force equal to, what is the formula? Capital G into what? M1 into what? M2 divided by what? D square. We know this. Here first, PO, F of PO equal to, what I can write here? It is G into what? 1 into 2. Why I am writing 1? This is 1 kg. This is what? 2 kg. D square, it is what? 2. This 2 get cancels. That is FPO equal to what? G. I am writing. Is it right? Okay. It is this force is acting along this direction. Next, F, this one, RO, I am writing, RO. It is acting like this, student. This is also same. 1 kg, 2 kg, distance is also what? Same. Equal to what? It is also G it is. No need to do this because mass is same, distance also same. Then FQO is also what? It is G only. This is acting like this. Okay. Now I will redraw the diagram here. This is your centroid. One force like this, one force like this, and another force like this. This is also what? G. This is also what? G. And this is also what? G. That is. Okay, fine. Students, remember, it is an equilateral triangle. Okay. This angle is 30 degree. This angle is 30 degree because it is 60 divided. 30 plus 30, how much? 60. So then this angle, it should become what? 120 degree. This will be 120 degree here. This is 120 degree. Now I want to calculate the resultant of this force and this force. The resultant will be what? Like this. What is this resultant? F dash, I will call it as F dash equal to square root of, you know that P square plus Q square plus 2P cube into what? Cos theta. That is G square plus G square plus 2 into G square into cos of 120 degree. What is cos of 120? Minus 1 by 2. So then F dash equal to, it is G square plus G square minus 2 what? G square into what? 1 by 2. Because we know that cos of 120 equal to minus 1 by 2. We know this. So that this get cancelled. 1 G square get cancels. So that F dash equal to square root of G square equal to what? G. This value is what? This is your center point O. Here at the center point O, what happens now? One force acting in upward direction, capital G, and another force resultant is also what? G here. Both how they are? Equal and opposite. So that at this point, the net force should be what? 0 only. Next. 17th. An artificial satellite is moving in a circular orbit along the Earth. Total energy is minus of E0. What is the potential energy? We know the formula. Potential energy equal to 2 times the what? Total. Of course, potential energy is negative. Total energy is also negative. So that 2 into what? E naught. And this will be what? Minus. Minus of what? 2 E naught. Next. 18th. A planet is moving around the sun, sweeps an equal area. A1 in what? 2 days. A2 in what? 3 days. A3 in what? 6 days here. You have to use the formula Kepler's law, third law. What is that? dA by dt equal to constant. That is, we know that it sweeps equal area in equal intervals of time. That is A1 by T1 equal to A2 by what? T2 equal to A3 by what? T3. Use this formula. T1 2 days, A1 by 2 equal to A2 by what? 3 equal to A3 by what? 6. You take the LCM and all that. Here it is 3A1 equal to 2A2 equal to what? A3. This. Product should be 6. That's all it is. 3A1 equal to 2A2 equal to what? A3. This is the right choice. Next, 19th. The distance of the Neptune and the Saturn are 10 to the power of 13 and 10 to the power of 12 respectively. Okay, assume that they are moving in the circular orbits, periodic times will be, which we have to use, t square is directly proportional to what? R cube. You have to use it. T square divided by t square of what? First one is Neptune, t square of what? Saturn. That is Saturn equal to R cube of Neptune divided by R cube of what? Saturn. Use it. This is distance of Neptune is how much it is? 10 to the power of what? 13 raised to what? 3 divided by 10 to the power 12 raised to what? 3 it is. Okay, fine. Then simplify it. What you are getting? Here t square of what? Neptune divided by t square of what? Saturn equal to, can I write like this? 10 to the power of 30 divided by 10 to the power of 12 raised to what? 3. Can I write like this? Here 10 to the power of 12 get cancels. This you are getting 10 raised to what? 3 you are getting. Then taking the square root, you have to take it here. That is square root, you have to take it. So that t of Neptune divided by t of what? Saturn equal to, it is 10 to the power of 30, nothing but what? 1000. 1000 raised to what? It is 1 by 3, like that. Okay. Then what you are getting is, you are getting roughly t square, no? The square root of this you have to take it. Square root of this becomes 10 into root of what? 10. Becomes 10 into root 10. Simplify it. Because I am taking the square root, no? This is the square root. Next. The Earth is at 1/4 of its present distance from the Sun here. The duration of the year will be, that is, okay. Again it is based on the t square is directly proportional to what? R cube. Here t dash square divided by t square is directly proportional to r dash cube. Okay, it is r dash cube divided by what? R cube. This is the formula. Here is said that it is 1/4 r dash, it becomes 1/4 of what? R. He said that. This is equal to 1/4 of what? R divided by R raised to what? 3. Either you can write capital R, small r, no problem. This R get cancels. It becomes 1/4 of what? 3. That is. But now I have to find it. T dash divided by t. Square root, you have to find it. It becomes 1/4 raised to what? 3 by 2. What is 1/4 of square root of 2 equal to what? 1 by 2 of what? Whole cube here. So that t dash, it becomes t into 1 by 2 whole cube equal to t divided by what? 8. It is 1/8 of the what? Present year. Next. A satellite revolves around the planet in elliptical orbit. Its maximum and minimum distances, has said that. This is the maximum. At this point, maximum. Here your sun is there. Okay. This is the distance. And this is the what? Minimum distance. At this point velocity is v1, at this point velocity is what? At this distance is r1 and this distance is what? Again it is based on the law of conservation of angular momentum, that is this distance, this. Here r1 equal to 1.5 into 10 to the power of 7. He has given this distance, students. And another distance is there. This is r2 equal to how much it is? 0.5 into 10 to the power of 7 meter. Now question is, which formula you have to use it? If the speed of the satellite at the farthest, means here that farthest, what is the speed here? Equal to 5 into 10 to the power of 3 is there. Now you want to calculate what is the speed at the nearest point. Nearest point. Nearest point means, as I told you earlier also, here the speed is what? More here. The speed is more here. Of course, all are more are there. Very difficult to judge. It is based on the m1, v1, r1 equal to m2 into v2 into what? Not m2. M is same. 1 meter. M into what? v1, r1 equal to m into v2 into what? R. It is based on the law of conservation of angular momentum. Students, remember, the Kepler's law says that law of conservation of angular moment. This m get cancels. v1 r1 equal to v2 into what? R2. I want to calculate v2 here. v2 equal to v1 into r1 divided by what? R2. Substitute. What is v1? Yes, given 5 into 10 to the power of 3. What is r1 here? 1.5 into 10 to the power of 47. R2 is this. It is 0.5 into 10 to the power of 47. Simplify 10 to the power of 7. 10 to, here 1 decimal. Here 1 decimal get cancels. It is what? 3. This becomes 5 into 3. 15. This is V2 equal to 15 into 10 to the power of 3 meter per second. But here there is no 10 to the power 10 to the power of there. Actually I said the speed is more. This is the right choice. That means I will modify it. V2 equal to 15 into 10 to the power of 3 into 10 divided by what? 10 and 1. What is 15 by 10? It becomes 1.5 into 10 to the power of what? 4. This is the right choice. That's 22nd. If the radius of the earth was shrinks by 1%, radius is shrinks by what? 1%. The mass remains same. The acceleration due to gravity on the earth surface is G equal to what? Gm divided by what? R square. Go to the units and dimension formula, percentage and all that. Here the mass remains same, only R changes, so that G is directly proportional to what? R. Percentage is asking. We know that delta G by G equal to, you take it to power, you have to take it left side, you write delta R divided by R. I did several problems on this. Percentage means delta G by G into what? 100 equal to 2 into what? Delta R by R into what? 100. Student, this represents percentage of change in what? Radius. How much percentage? 1%. So that 2 into what? 1%. So that delta G by G, it changes by how much? 2%. 2%, what happens? You see? Of course, here also 2% is there. Here also 2% is there. G and R, how they are related? Inversely related. So that if R decreases, G will be what? Increase. So that increases by what? 2%. A simple pendulum has a time period T1 when it's on the Earth's surface and T2 when it is taken to a height R above the Earth's surface. Remember, one shortcut I told you in the regular class. This is your Earth's surface R. When I am going at a height, this is the height. This height h equal to r. Remember, shortcut method. This is g. At this height, g dash becomes g by 4. Remember, don't waste your time. At a height h equal to r, at a height h equal to r, always g dash will become 1/4 of it. Alright, he is asking simple pendulum. T equal to 2 pi square root of L divided by what? G here. T and G, how they are related? Inverse related here. So that can I write T2 by T1 equal to square root of G1 divided by what? G2. Can I write like this? G1 is nothing but G. G2 is nothing but G by what? 4 here on this. Yes, write it. T2 divided by T1 equal to G1 is G. This is G by what? 4. So that this G get cancels. It is square root of 4 equal to what? 2. Therefore, T2 becomes 2 of what? T1 is. Choice is that? That's the choice.